Okay, so good evening, guys. So welcome to KodeCamp 3.0 Android beginner training. Again, my name is Gage Kratchum, as you all know. So today we're going to be looking at object-oriented programming, that's OOP, right? We're still continuing our Kotlin journey, and we should round that up today. From next week, we should go straight into mobile app development. We're going straight into Android, right? And yeah, so see how to round this up today. Okay, so yeah, we're looking at object-oriented programming. So yeah, what's OOP? Basically, it's just a programming pattern, right? But people use the word paradigm, but paradigm pattern, whichever one, that organizes your code into objects, right? They organize your code into objects, which are basically instance of classes, right? Objects is actually an instance of a class. So OOP is just a way of structuring your code based on the concept of objects, right? Based on the concept of objects. That's basically what OOP actually what is, right? Now, objects are basically just entities that kind of encapsulate data. When they talk about data now, we're talking about attributes, and also encapsulates behavior. Now, we'll talk about behavior. We're also talking about methods or functions, right? So the aim of OOP basically is just to kind of model real world entities and how they interact in a more intuitive and organized manner, right? So that's just me giving a brief introduction, right? But we're going to talk about when we talk about OOP, right, we basically are going to talk about two major things, which is classes and objects, because like we said, OOP, which is object-oriented programming, is a programming pattern that focuses on organizing your code, right, into what objects. So that's why I said object-oriented programming, right? So Kotlin is actually an object-oriented programming language because it kind of focuses it aims to model your code like an object. And yeah, so that's that. So but let's talk about yeah, I've said more. I've mentioned objects, I've mentioned classes, right? But what are these things, right? What are these things? What's an object, right? What is a class, right? What do these things actually mean, right? So let me just keep this. Okay, let's run this. So basically, let me give an example. But by definition, we'll start with objects. An object by definition is an instance of a class, right? By definition, right? So when we talk about OOP, right? OOP style of programming, we are basically dividing a complex problem into smaller sets. And we do that by creating objects. Now, objects, right, have two characteristics, which we call state and behavior. Okay, state and what behavior. So let's get into our one code. But basically, what we're going to cover, we're going to talk about classes and objects. We're going to talk about constructors. We're going to talk about what we call getters and setters, and then we'll talk about inheritance. Right now, after this, we're going to get into next week. We're going to get into Android, right? But we'll also come back to the whole concept of OOP. It's a bit large, right? A bit, but we'll just take it slow and steady, right? While also running, getting our hands dirty. So you may want to start prepping your Android studio, right? And cleaning whatever dust that it has actually accumulated based on, it hasn't been used. Okay. So that's basically what we're going to cover. So let's just, let's get started, right? Let's get to our one compiler rather. I call it one code. Okay, so please confirm you can see my screen. So we move on.
Yes, I can see your screen.
Okay, so let's go. Okay, so like I said, we're talking about objects, right? So objects basically is just an instance of a class, right? Now, objects they share two properties, state and behavior, right? So let me use a comment. So state, right, and behavior. Okay, I think this dark mode, the text for this dark mode for comments, well, state and then behavior. So those are two properties of an object. Now, let me give you an example of an object. So that would actually just help you to understand it more. A typical example of an object is, let's say, let's say a lamp, right? Let's say a lamp, right? Now, a lamp is an object, right? Lamp is an object, okay? Now, it has a state, right? And that state is either it is in an on or off state. Am I right? It's either the lamp is on or it is what off, right? Now, it also has a behavior, right? It has a behavior, and its behavior is you either turn it on or you turn it off. That's the behavior, right? Let me give us another example of a lamp, of an object rather. I'm going to go with a car, right? Now, a car has a state. The state there basically has to talk about, also talks about properties, right? So for example, a car has a color. Every car has a color. Is that not true? Right? What else are the properties of a car? Somebody should just, let's talk randomly, either on the chat or you on mute. I need to get you guys engaged or involved. So can just list out. Yeah.
Tires.
Okay. It has tires. Every car has tires. What else?
Year of production.
Year of production. Okay, that's fine.
Doors, number of doors.
No, good number of doors, right? So let's just work with this. So these are what states or properties, right, of an object called what? Car. Now, for behavior, right? Behavior, which has to do with methods, right? Sorry about that. Behavior. Now, every car, what is it? What to you, what's a behavior of a car? Right? Can someone help me out? Behavior. What behavior does a car object?
Accelerate.
Okay, every acceleration. Okay, good. Accelerate. Yes. What else?
Decelerate. Brake.
Brake.
Ignition.
Ignite. Okay, you can start it. Corey, go ahead. Just don't worry. Forget the raising of hand. Just say what you want to say. You don't know where it's still, your hand is still raised. You can talk, you can speak, or you can use the chat, whichever one is convenient for you. Okay, so that's actually just that. Now, so braking, you can actually brake. Every car accelerates, right? You can also change gears, right? You can change gears, right? Either manually or it does it automatically, right? Gear change. So that is what the behavior of a car, right? So we'll learn more about this thing, these things as we keep going, right? But that's just the characteristics of an object, right? And an object, by definition, right, is an instance of a class. So now the question is this: what is a class, right? What is a class? So basically, a class by definition, right, is just a blueprint. A class is just, you can actually just leave it as this, like this. It's actually just a blueprint, right? But let's just say it's a blueprint for an object. So think of a class as this. Now, when you want to build a house, you go to probably an architect, right? And what do? They kind of just draw out your house. They give you an architectural, design that, okay, shows you, okay, fine, this is, let's say, it will have 5 rooms or whatever. This is the distance between these. This is where windows can be. They just give you a kind of like an architectural design, right? Now, the thing is, the same architectural design can actually birth 5 or 6 different type of houses, right? So an architectural design, right, can give you houses with different looks. Same design, right? Same structural design, same blueprints. Okay, I'm going to have 5 rooms, right? okay, let's say in the 5 rooms, it has one parlor, one major parlor, one dining, it has 3 rooms, you have a place for swimming pool, whatever. That's just the structural design. That's just a blueprint. That is a class. A class is actually a blueprint for your what object. Now, what an object now does is, it's an object, like we said, is an instance of a class. Instance of a class means that an object, basically, you birth an object from a class. So an object takes the properties of that class, right, and modifies it in a way that it suits them. That is why every listen, for example, a car is actually a class in itself, right? But you can see that everything we have mentioned here, every car has color, in as much as we have different kind of cars. We have different types of cars. We have Mercedes, we have Ferrari, we have, Boss, everything, they're all cars. But you notice that each of them are distinctive by either their color, by either their style, right? By the brand also, right? A lot of things. But the major thing is that they all what? Accelerate, right? They all have the ignition, the brake, they change gears and everything, but each of them does it in their own way. That is why you see some cars, they have, since cars have brake generally, right? But some is what? Automatic, some is manual, right? Cars have ignition, some you use key, some they have modified their own to just use a button and you press. Some can be probably voice activated, right? So a class is a blueprint, right? An object is an instance of what? A class. So an object just takes that blueprint and what? Brings out, brings to life that class, but in a different way, So that's why every car has these things, but when you see a Mercedes, it looks different from a Ford, right? Each of them, Ford is an object of the car class. Mercedes is an object of the car class. Volkswagen is an object of the car class. They are all objects, but they all belong to what? A class. So don't worry. Well, we're going to write some code, right? That will actually get you to see these things. So that's just it. So you can just think of a class as a prototype of a house or as a sketch. It contains all the details, like I've actually said, it contains all the details. Maybe number of floors, number of doors, number of windows, right? So based on this description, you build the house. So the house itself is the object, right? So just take note of that. So how do you define a class? We'll start with that. How do you define a class? So it's very simple, just like the way you define a function. You use the keyword fun, and then the function name and the like. So, but for a class, to define a class, we use the keyword class and then a name. You give it a class name, right? And then you open your curly words brace. This is just a way to define a class in Kotlin, right? So in your class, you now have 2 things. You have the properties of that class, and then you also have the what we call the member functions. So what would say member functions? We're just saying functions that belongs to this class, right? Member functions, or you can just say functions, right? So that's how you actually would define a class. Okay, so let's actually now use a valid example. So I'm going to create a class, and let's use this lamp example, right? I'm going to call this lamp, right? So whenever you're defining a class, the first letter of the class name, right, it must be what? Capital letter. And then every other first letter of this is, so if you're having my lamp, the first word there is my, so it will be capital letter. The second word there is lamp, so it will be capital letter. Every other thing small letter, right? So, but of course, if you're defining a function, you start with this lowercase. Take note of that. Okay. So let's say let me just start afresh. Let's say I want to create a class called lamp. Okay, good. Now, for property, let's now state the properties of this lamp. So of course, properties are just variables, right? So I'm going to use private. So you're going to be seeing me use private, and these are what we call access modifiers. I will talk about them later. But private var and then is on, because remember we said one of the properties of a lamp is either it is on or off, right? That's just it. It's just those two, nothing else. It's just a lamp. It's just on or off. So, and that is Boolean. It's a Boolean, right? It's a Boolean, because if I ask you, is the lamp on? What will you tell me? Is yes or no, true or false? Okay. So I'm going to say it's false, right? There's no light. Okay. NEPA is not giving us light. So we'll say false. The lamp is, let's just use false. Now, that's just a property, right? And okay. Now, how about for functions, right? How about for function? So let's say the member function. What function can exist in this class, right? Of course, we had already talked about it, right? One of the functions that can exist, which is a behavior, is that you can either turn the light on or off. That's basically that. So that means since it's a function, I'm going to create a function called turn on. You see how I started with small letter T and then capital letter O, right? So the function name is going to be turn on, and then I'm going to open my curly brace. And then what do I want to do in this function, right? What do I want to do in this function? I want to just turn on the light. That's all. So what do I do? To turn it on, I already have this variable called is on, and as at this place, the value here is false. So because it's a var, I can update the variable because it's a var. But it's a val, which is a VAL. Of course, I won't be able to do that. So I'll just say it's on, and then I'll assign true. That's just it, right? Now I can also, another function, member function, is a function to turn it off. So I'll say turn off, and then it's on. I'm going to assign false to turn it back off, right? So that's that. So what have we done? We have actually just defined a class called lamp, right? And the class has one property, just one property, right? Called is on, right? And you define properties just like you just actually do a variable, right? So, and it has one property and two member functions. Okay, but I've talked about functions, so I'm not really going to go into that. Okay. Okay, so let's move on. So classes, let me just talk about this quickly. Classes, objects, properties, member functions, all these things, they can have what we call visibility modifiers, right? Visibility modifiers. So for example, you can see I have this word private here. I might be wondering what that means, right? So basically, this means that setting this to private means that this property called is on can be changed from only inside this lamp class. You can only update it inside this lamp class. You cannot update it elsewhere, right? You cannot update it in another class. Okay, so we have other visibility modifiers, right? Like we have public. Public is a visibility modifier, right? By default, whenever you create a class or a function, by default, it is public. What does this mean? It means that it is visible everywhere. It is visible everywhere. But private, is visible, but can be accessed from inside the class only, right? So if I try to, in my main function, because, so first of all, sorry, whenever you're creating your class, you don't create your class inside a function, you create it outside, right? So take note of that. So you can see that if I want to, I can't call, I don't even have access to it. I can't use is on here. Let's say, let me show you. Let me imagine I try to print is on, right? I want to print the value of is on. Okay, so if I run this, let's just see. So you can see it's unresolved reference. unresolved reference is on. So it can't actually see it because it is hidden in this class. Okay. Now, we also have the protected. Protected means it is visible to the class and also its subclass. So you can have, just like you have, we talked about recursive functions where you have a function inside a function. You can also have a class inside of a class. We call that nested classes, nested, Nested. But we'll look into that, right? We'll get to that, well, especially when we get into Android, right? But that's protected. The last visibility modifier. So let me just, so we have public, we have private, we have protected, and then we have internal, right? Internal just means any client inside the module can access them. Don't worry, just know this one. We'll get to use it much later. Okay, so this is just me, kind of dropping that out there. So now we have created a class. Remember, we said a class is just a blueprint, right? It's a blueprint for an object. So an object only exists when there is a class, right? An object only exists when there is a class. So what are objects? Like we said, an object is just an instance of a class. That's just what it is. Because when you create a class, okay, when you create a class, remember when we talked about variables, right? We said variable is a space in memory. When you create a variable, you're basically just told the computer, okay, you've told the compiler, that, hey, I've created a variable and I'm going to be storing 32 bits information. So once you create a variable, an integer variable, for example, it creates that space in memory, 32 bits. Right? That's 32 binary integers. It creates that space already. So even if you don't put anything, it has created it. Nothing else can take it. There's nothing that can take that space, right? So when a class is defined, only the specification for the object is defined. So it does not allocate memory or storage. So we have created a class now. It does not store it. It does not allocate any memory, right? Until you create an object. So, and another thing is this, to access these properties and members, the properties and the member functions, right? You need to create objects, right? You need to create objects. So that's why you cannot decide to start building your own car without first of all knowing what makes up a car. You can't do that. You just cannot, because the truth is this: whatever it is, whatever kind of car you probably saw in your dream, right? That something somehow the universe told you, gave you a design idea. It's coming from somewhere. There has to be something on ground, right? So you may decide that, okay, fine, in your own car, it definitely has to have wheels, or except you want your own to fly in the air. Then that means it takes a particular configuration which is already existing. So you're basically building on what has been there. Not like you're going to start afresh and probably decide that your car, you want the bonnet to be in front, right? Sorry, the bonnet to be behind and the boot is now in front, right? You can do that, of course, that's up to you. So that's Kotlin objects, right? So how do we now create an object of this class called lamp? So it's very simple, right? You create an object just like you would create a variable. So, or declare variable rather. So I'm going to do that in my main function because we're going to use that object to do a few things. So I'm going to say val lamp1. I'll just call it. So I'm going to call it lamp1. That's just a variable name. And I'm going to use the assignment operator, right? And then I'll call the class, right? And then initialize this class by putting these parentheses. We'll talk about constructors, right? And why we should have that parentheses there. Because if you don't have this, if it's just like this, if you just call the class like this, it won't work. Just like if you're calling a function, you have to put that parentheses there because it actually indicates that there is either a parameter or an argument or there is none, right? But it's called a constructor in a class. So we'll talk about constructors, right? But this is basically how you create an object. So you can create more than one object, right? I can decide to create another one called lamp2. Yeah. So this creates another object, right? So basically what I've done is just to create what 2 objects of this class called what lamp. So now by default, okay, the is on property is false, right? And then the function to turn on, and also this property is going to be false for these 2. For these 2 objects that we have created, the property called is on is going to be false by default, because they are now, you're not creating an instance from the class. Creating an instance means it now accesses or has the same properties as the class until you modify it yourself, right? So that's how you create an object. But how do you now access the members of the what class? Right? How do you access the properties and member function? Because yes, just because you created the object does not mean you can just automatically, you have to access it. You have to access this properties and methods. So how do we do that? It's very simple. All I'll just do is I'm going to just say lamp1, and then we use our dot operator, right? We use this dot notation or operator. We use it to access the properties, right? Just like you've seen me use it before. We have used it to do dots to string and all those stuff, right? That good. So interestingly, when we are doing that, we were accessing methods. Like when you see dot to string, right? Dot to int and all those stuff. You're accessing methods of a class that you have not seen. But now we are creating our own class and accessing the methods ourselves. So I'm going to say lamp1 dot, and then you can see I have access to is on, right? But I also can do dot turn on. So let me do this. Let's do something. So lamp1 dot is on. I want to change the variable to true, because the variable here is false, right? The variable here is false, right? So let's run this. Let's run this and see if anything is going to happen. So first of all, you can notice I did not, there's an error here. So you can see I did not put the parentheses, and that's why it says error. Function invocation expected. So it's expecting this guy. So I'm just going to put that here. And then you can see that here it's saying that it cannot access this guy. Lamp1 dot is on. So it says error cannot access is on. It is what private. You see that it is what private. That's why it cannot it can't actually access it. So then we take that out and then run this. Then we should have access to that. So good. So it's just telling you, okay, let's take out this. This lamp2 is not used. So it's just a warning. We're not using it. So let's just take it out. Let's just take it out. Okay, so when we run this, you see nothing happens, right? Because we are not printing anything to the console, right? So nothing actually happens. So I can say now, if you notice, this turn off actually just does something. What does it do? It changes the variable of this is on. That's just what it does. So let's do something. First of all, let's just clear this. Let's confirm. I want to print or print line lamp1 dot is on. So let's see if we're going to see false, because I'm just assessing the is on property that is actually here. So you can see it is what false. So with the object, I have access to the what property, and I have access to the property and anything that accompanies it. So the property there already has a default value as false, right? So this after printing this, let's now try something. I want to change the value of is on to true. So if I change it, let's now print is on again and see if it will change. So let's see what we'll have. We should have false and then true. So yeah. So the first time printing it, the default value false, and then we updated it. So with the property, you see we can now update the value, right? The object can now update the value. So it can now use that property the way it actually wants, right? So we updated it to true, and then when we now print it, you can see it's on is what's true, right? So, but instead of doing it this way, I could just say lamp1 dot turn on, right? And what does turn on do? Turn on actually does what we wanted, what we actually did before. It changes the variable to what's true. So I'm going to just copy this, and then I'm going to change this to turn off, and then let's see if the value what changes. So when we run this, we should have false, true, and false. Yes. So we have false, true, and then false. Okay. So that's actually, that's basically how you actually, create an object. So what have we done here? We've basically created a class called lamp, right? And then the class has a property called is on, and two functions, right? To turn on the light and to turn off the lamp, right? Okay. So we now created we created just one object. We created two before, but we're just using one. We created two objects, sorry, one object, right? In the main function, right? And then we are printing the value of is on, right? Using the object. So we say lamp1, and then using the dot operator. So the dot operator gives you access to the member properties and member what functions, right? So we could access that. And of course, the value of is on is false. That's why it printed false. And then we then called on the turn on function, right? Using the object, and it turned it on. Turning it on means it changes the value of the is on from false to what's true. And then when we printed that, we have true, and that just keeps going, right? But let's actually now let's update this, right? Let's update this, because I want to be able to kind of do something a bit more interesting. So I want to add one more function, one more member function here, and that function is I'm going to say display light status. So I want to display the status of the light, right? Okay, I want to display the status of the light. Sorry, trying to bring things up a bit. Okay, so what is what I want to do? I was just going to say if is on is actually true. If it's on is true, what do I want to do? I want to print lamp is on. Else, okay, so let's since we're just doing only one thing, right? Let's just actually write a much more cleaner code, right? So if is on is true, print this. Else I want to print lamp is off. Yeah, I want to print lamp is off. Okay, so I think that's that. So that's what we want to do. So we're just checking the value of what is on. So if it is true, then that means the lamp is on. If it's false, then that means the lamp is actually what's off. So we can actually just test that out, right? We can test that out, and I'm just going to do lamp1. So for example, if I just say lamp1 dot display, you can see I now have access to the display light status function. So when I call the function, of course, what will happen? It will tell me that the lamp is off. Why? Because when it ran this function, okay, it checked for this variable, and this variable is what false. So that's why it printed what the lamp is what off. Of course, if I want it to print the lamp is on, it means I have to update this variable. So I probably will just have to say var lamp1 dot is on equals true, right? So let's see if that will work. So well, basically you're just changing it, but when you now still do the whole display live status, right? Sorry, it says local extensions are not allowed. Oh, sorry. supposed to just use the object. I went to create a variable. Sorry about that. Okay, so yeah, that's actually that. So you see, first of all, I changed the value of the is on. I turned it on, and then I'm now displaying the light status, and then it checked because I've already turned it. I've changed from this code. After I changed the variable, I'm now displaying the light status, and this on is actually now true. So it means the lamp is actually what? On. Okay, so let me stop here. Any question before we move ahead? Any question?
No, sir. No questions for me.
Okay. Okay, so let's move on. So the next thing we're going to look at now is constructors, right? Constructors. So a constructor basically is kind of like a way to initialize class properties. Okay, that's what a constructor is. So basically, what I'm basically explaining is this guy. See this parenthesis here. That's basically what when you want to create an instance of a class, if you just call the class name without that parenthesis, it won't actually work. All right. And I think we saw that. So a constructor is just a concise way to initialize class word properties. So it's kind of like a special function that is called when an object is instantiated, or created. Let me use the word created. All right. So it's just a special function that is called when an object is what created. But they kind of work a bit slightly in Kotlin. So I'm just going to talk about that right now. In Kotlin, right, we have what we call a primary constructor. Sorry. We have what we call a primary constructor. Yeah. So, and then we have the secondary constructor. So the primary constructor basically is kind of like a concise way to initialize a class, right? But the secondary constructor allows you to put, some additional, initialization or logic. So when we're talking about initialization, of course, we have talked about what it means to initialize a variable. It means you're giving that variable a value, right? So when you want to initialize a class, right, you're basically now presenting, you're giving your object what the values that it needs, because of course we said that the constructor is a way to initialize class properties. So it's a way to take the properties and give it to the object to make use of. Okay, so we have the primary constructor, which is actually the easier, concise way to actually do that. But the secondary constructor actually allows you to put some additional, initialization, right? Maybe there's a few more things you probably want to add, and you only want to add it when it is needed, right? So we're going to actually let's take this example. So I'm just going to clear this, right? So I've actually, so this is what's going to happen, right? I'm going to share this with you guys though. So let me just, instead of deleting it. Okay. So let's create another class. So this class, I'm going to call it person, right? So as a person, what properties do you have, right? So now we want to talk about primary constructor, right? And the interesting thing about primary constructor is that whatever property you put in the primary constructor, it must be initialized first before you use it, right? You must give it a value before you use it, right? So the primary constructor is usually part of your class header. So when you're creating a class here, inside this parentheses, I can now say, I want to give it a property first name, because as a person, of course, you should definitely have a first name. And then you have an age, right? you have an age. So these are the two properties that a person must have. Everybody has a first name. Everybody has an age. Now, but the thing is, everybody can implement their first name anyhow they like. You can your age also anyhow you like. Okay. So and then of course inside here we're going to have the body of our class, right? So but this place here that is surrounded by these parentheses, right? This is the primary word constructor, right? This is the primary word constructor, and this must be initialized first when you want to use the word, when you want to actually call this class, right? When you want to create an object from this word class. So we have declared two properties here, first name, and we're using a val, meaning that it is read only, right? And then we also use the age, and we're using a var for the age, means that you can actually read and write, you can change it, right? So let's, assuming I want to create an instance of this class, what would I do? The same way, right? The same way. So I'm going to say var, let's say val person one, right? And then I'm going to now call the class name, which is person. And then I will now pass in the two properties that was actually stated when we were creating the class, we're defining the class, right? So probably just say Ima, and then for age, let's give her 16, sweet 16. Okay, so that's that. So that's how you create an object from that class, right? A class with a primary constructor. And very simple, you can just, with that object, right, you can just print, I can just say print person one dot first name. So if I want to print this, the first name now should show as Ima, because that is what we gave here, for the first name, right? You can see that the first name is Ima. Okay, so that's actually the concept of primary constructors, right? That's the concept of primary constructors. Now, another thing you can also have is, because if you notice, you can also have remember an initializer, right? You can have an initializer. So the primary constructor has a more like a constrained rule, right? It actually cannot contain any code. So you can't put any code here. You can't put any logic inside here. You can't put any logic. But what if you want to actually add a logic that you want that logic to run at the point where you initialize the class, right? At the point where you create that object, you want that logic to be what's there. How can you actually do that? Okay, so to do that, we use what we call an init block, right? An init block. Init means initialization, initialization, right? So that is initializer block. So we put our code in the initialization block, or the initializer, right? That's what we do. So this is an example still with this, right? But instead, I'm going to just take this val out, take this guy out, right? And then I'm going to declare it in the body. So I'm going to say val first name of type string. And then I'm going to say var age of type 8. So I want to create them in the body, not inside this constructor. And then I'm going to now call in my init. So we use this keyword init to initialize. So at the point where you're creating that object, it will just initialize to run this init block first, right? To just run that. So what do I want to do in the init block? I want to say the first name should be okay, so let's change this so that it's not confusing, right? And let's call this her age. Okay, good. So when you are initializing it, right? So here we're just creating two variables, right? Two properties. And then here we're also we're calling, giving to more like a property also, but a variable, such that when you actually initialize this class, so want to say that the first name here, you should take, remember what is here is basically what you're going to actually impute the values. So what I want to do is that I want to take that value and store it here. So the first name should be F name. So whatever the user puts, whatever you put as F name is now passed into this place, right? And then, but I want to do something. I want to capitalize it. I want to capitalize it. So capitalize, it's actually a member function for strings. And then for the age, I just want it to be the person's age. Which is her age. So inside that initializer, right, I don't want to, I want to now print first name, and I want to print age. Okay, so yeah, so when we run this now, what do we now have? We already created the object here, so I'm still leaving it this way. So you can see we still have Ima and what, 16, right? Okay, so but this capitalize is not working. Don't know if it is from this what's it called, this particular one compiler, but this is actually supposed to capitalize the words, you know. And let's see. Okay. Okay, so well, maybe I'm missing something though, but let's move on. So, but that's actually how you use an initializer, right? The init block, right? So because you see this logic, we can't actually do this logic here inside the primary constructor. You can't actually do that, right? We can't actually do that in there. So that's why we actually now created the, what's it called? Created the init block to actually just do that for us, right? So yeah, okay, so well, yeah, I've got, it's actually working. So I think I'm mixing it up. So the capitalize function, actually what it does is that it returns the first returns back a string where the first character actually is uppercase and the rest is, you know, lowercase, right? So if I were to actually do email with a small letter I and run it, okay, it will actually give us back, it will return the string, which is her name, with a capital letter I. If I take out this, we should see small letter I because I've taken out that function. Yes, so that's actually that. I think I was mixing things up. Okay, so let's move on. So that's actually the whole concept of the initializer, right? The init block. Okay, that's the concept of the init block. Okay, Ahmad, go ahead with your question.
Yes, sir. Evening, sir.
Yes,
Can we have different values for the F name and the first name?
Can you have different values for the F name?
F name and the first name.
Well, no, you can't have different. If you check what we are doing here, the F name is whatever we type here, right? And inside this class, we are taking that F name, right, capitalizing it and storing it in this variable we created. So this is just an empty variable we created, just a property, right? So basically what we're doing is we want to distinguish the constructor parameter. This is the constructor parameter, right? Or argument. We want to distinguish the constructor parameter from the what property. This is the property, right? So we use F name and first name, and then we use her age and then what age, right? Actually, the most common way to actually do it, right? The most common way to actually do it is to still use, which I think, well, let me just introduce that, is to use an underscore, right? This is the most common way to actually do it. Yeah. So this is actually the most common way to do it. So here I'm just going to. So we're just distinguishing. I can use the same first name, but of course it doesn't. You shouldn't create two variable the same name, right? So running this will still give us what we want. Okay, so just take note of that. Now, another thing is you can actually have a situation where you have a default value in your primary constructor. You can have a situation like that where you have a default value to your constructor parameters, right? So if you check here, our parameters here, we're not giving a default value, we're just declaring the parameter. And then when we create the object, we now give it the value, right? But you can also put a default value. Like for example, I could say first name of type string, and then I'm going to assign which other short name is here? Okay, let me use Ahmad. Right, so this now is a default value. I'm giving it a default value. I can also give a default value for the age. Ahmad, go ahead. And let's say
Yes, I'm still not clear on that because we are having first name twice, assuming the underscore is not before the first, like you wrote it before. Can we just have, if you only have first name as property and not in the constructor, can't we just do with the first name only?
Okay, I think you're missing. Let me try to get you. First of all, there's a difference between the parameter, right, and the property. The first name here is a property of this class. This is a parameter. Parameter being that, or argument being that this is what the user will pass in. It can be anything. So we are taking whatever the user is passing in, and we are storing it in this we are using it to update, to store in this parameter. That's what we're doing. I don't know if you're getting. So it's not like you can't have, we have already gone through the first parts where you can actually just, take this and put inside the, what's it called? The constructor, where you have that. So you're just using it as a parameter and also as a property. But here we are actually now, we want to define a class in such a way that it has a primary constructor value, right? It has a primary constructor value, and by convention, okay, let's say first name is part of it, we use an underscore by convention. Okay, I don't know, does that make it clear? So just first of all, understand that parameter, property, they are different things. Parameter is what is required to create your object. Property is a part, more like a member of the class, the things that make up that class. Okay, so I don't know if that actually makes things clear.
My point now is, can we just use property only when it is
Yes,
required?
we did that. We did that. We already went through using only property before we got to this point, right? We already yeah. So we definitely went through that before we got to this point. You can actually use just that. You must not use this. Ima, go ahead.
Okay, what if we want to get input from the user? Like, because I do not know if I'm mixing up inputs with the objects. Because if this is the parameter and then we are still putting it in the object, we still have the name. Let's assume the person is supposed to input is the person's name and age. How, I don't know, can you please
And
explain
it's
that part?
the same way you would actually, the same way you get inputs, right? Let's say you create a var name, and then you do your read line and blah blah blah. Whatever the user types is stored here. You can just take that and just put here. Do you understand? And that will still work.
Okay, thank
Yeah.
you.
Yes. Okay, so let's move on. So, well, you guys should just need to bring in your thinking cap because it's getting, we have moved past the very, very simple stuff. Okay, so let's move on, right? So that's for the primary construct. So where was I, right? Okay, yeah, default values. So here we're giving a default value, right? We're giving a default value. So because of this, because we are giving a default value, I can now create, I'm going to create 3 objects, and then we're going to see something, right? So let me first of all just do a print statement, print line, So here, just going to say person 1 is instantiated. So when I use the word instantiated, I also mean created. But I want you guys to get used to the nomenclature, right? Get used to this naming convention. Okay, so let me paste this here. And then let me also paste this here. So, okay, so this should be person 2. This should be person 3. Person 2. Person 3. So now I'm going to change this to Ahmad for this particular object, right? I want to change it to Ahmad, right? And then for the age, I want to say 18. And then for this, okay, in fact, I don't want to put age. And then for this one, I don't want to put anything at all. Okay, I don't want to put anything at all. So we have 3 objects here, right? So when we create this one, when we create this object, as part of the init block, it should print the first name and the age as part of, because remember we said this is going to this initialization block, of course, when you just call when you create an object, it actually runs. So let's me click on run, and then let's see the output we are going to have, right? Let's see the output we are going to have. So you see the very first time when person 1 was instantiated, that means when we created the first object, it had Ima and it had what, 16, right? So but we have a default value here of Ahmad and what, 18. But because we gave it a value, we basically just more like it's called an override, right? Past tense will now be overrode. Okay, then we have overridden. So we overrode the default value of Ahmad here and the age also. When we created the second object, which is person 2, okay, let me change. Ahmad is still there, so let me put Jane, and then let's run it again. So we see that we now override what was already there. So you can see we have Jane, but we did not put anything for what age when we were creating this object, but it still gave us what, 18, because that is the default value of what age. Same thing here, when we created this third object, when it was instantiated, we didn't even pass in anything at all, but it was still able to run this code and still have this, because this is the initial this is the default value, right? Ahmad and then this. But of course, if we did not have this here, right, there will be nothing for you to actually print because there's no default value. In fact, all this would actually give an error because there's nothing to actually pass in. Okay, so that's actually about primary constructors, right? Now, but when we now want to go to secondary constructor, remember, now in Kotlin, a class can also contain 1 or more secondary constructors, so it must not be 1, right? You can actually have 2, 3, 4, 5. In fact, you will get to see it in Android. There are classes that have up to like 6, 7 constructors, right? Now, but what's the essence of that, right? Secondary constructors, now they're not really that common in Kotlin, actually. They're not really that common, right? But the most common use actually of a secondary constructor is when you want to, when there's a need to extend a class that actually provides multiple constructors, right? You'll see a lot of that once we get into Android. It's very, very well clear, right? But we'll learn about how to do that when we talk about inheritance. We'll talk about inheritance. Okay, Olauju, will go ahead.
Okay, so I wanted to ask a question. In this constructor now, for example, I know we in the declaration of persons, we had the initial parameter of Ahmad and 18. What if we add just Ahmad or just 18? How do we instantiate the person?
So because you've given it, and that's you can see this example I gave here now. When you're instantiate, you're basically creating an object. So when you create an object, the second person here, we only provided Jane. The person class, the constructor requires 2, but we provided only Jane, right? And then it overrode Ahmad to give us Jane. And then since we did not pass in anything for the age, it took the default value.
Yeah, I'm saying an example where we declare just Ahmad as the default parameter, and we
Okay,
did not
this
initialize,
is what you're wait, this is what you're saying.
like
We
we did not
declare just this.
no, we declared both true, but we do not initialize the age.
That's when you say initial, that's what we're saying now. This
That
is
int
what it does.
that int is equals to 18. That's what I'm saying. That we
Okay,
didn't.
okay, so we don't do this.
Yes,
Okay, this is what you're saying, that we don't
yes,
do this. So if you don't give it a default value, right, it
yes.
means that you must pass in something,
Okay.
right? If you don't give it a default value, you definitely have to pass in something, right? So you can see here, no value passed for age in this error message here. No value passed for age, no value passed for age in the, you get, so in the first one, it didn't give us any error because we passed in a value for age. But you see in the second, object, you see this here, no value passed for a third object, same thing. Is that clear?
Yeah, I think I know how to do this for line 27. How do we pass the age so that the code will decide
And just the age is an integer now, so you just give it an integer value.
age alone? You start passing the name since we already have a default name.
Okay, so that's what I'm saying. So let's look at this now. Let's look at this. So let's run this. So we learned something in the last class in functions, right? We learned something in functions. Now, the reason it's giving an error now, right, is because you can see that it says first of all, in the this third object, what's the error is saying here? It's an error, the integer literal does not conform to the expected type. So it is expecting string first, right? It's expecting string what first. Now, in the last class, we talked about, I don't know how many of us can remember. In fact, let me even check. Let me pick our brain. How many of us can remember? We talked about default and named arguments. I don't know if you can remember default and named arguments. Nobody can remember. That's lost. Eh? You guys have thrown it away. You've thrown it away. Okay, so we talked about default and named argument, right? And so basically what that means is this. The class here, just like a function, it's expecting a string to come first, right? Before the age. But here we are putting the age first, right? We are putting the age first. So that's why it's actually seeing it as a problem. So what you would have actually done, of course, when we looked at named this thing, is to say that age equals this. This is what you would have actually done in when you're actually setting up when we talked about Kotlin named arguments, and that actually just solves your problem. So because you want to just pass in only the age, you have to explicitly tell it that, look, it is age, is the value for age I'm giving. I'm not giving that of string, because from the definition, when we are creating the constructor, we put string first, age second. So if you just put only age, it takes it that that's the very first input parameter. But the first input parameter is expecting is a string. So what we do is now call the name and say, okay, hey, age is 29. I'm not giving you anything about string. It's just age that I am giving you. Okay, so does that clarify things for you?
Yes, it does. Thank you very much.
Okay, good. Okay, so that's primary constructor. So we're talking about secondary constructor, right? So yeah, so how can you actually create a secondary constructor, right? Basically what you just do is you just use the keyword constructor. That's just it. Like, that's just it. We just use the keyword what constructor. So let me use a more let's change this example. I want to use something a bit more tricky. Like I said, we have moved past the simpler things, right? Let's start doing a bit more. So let's look at secondary constructors. So I'm going to create a class for it, right? So I'm going to create a new class. Let's call this okay. So I'm going to let me just use. So let's first of all, I'm going to create a class called log. So I'm going to use one bird to kill two stones, right? I'm going to give you a hint into inheritance right now, but let's just do this first. So let's say I'm creating a class called log, right? And here, in the log, I have a member variable called data, which is of type string, and I'm initializing it to just an empty string, right? So once I put quotes down, it's just an empty string. And I'm going to also check the number of data. A variable is 0, initializing. So I can now create a constructor using the keyword constructor. And I'm just going to say that, okay, in this constructor, it takes a data variable, just data alone. That's just what it does. In this constructor, it takes only what? Data. That's what this constructor does. I can create another constructor, right, that takes both data, right, and number of data. So you can see why I'm using the one with underscore, because we're going to just initialize that. So, and that's going to be of type int. And what this one will do, so our data, which is this guy, the property, whatever the parameter is, we'll store it in the property and use that. And then the number of data, because we're storing the number of data. So we want to now print, let's say, okay, let's use a, say data, number of data, nope. Number of data. Okay. Okay, so let's just do, so we have two constructors now. So just think of a constructor like this, right? Just think of it as more like a variation of your class. So if you notice, when we created this class here, we did not give it any parameters. We did not, if we had done this, it means at this point, our constructor is empty. It doesn't take anything. So just think of it as variations of your class, which you can call, you can create an instance of, and you use any instance of the class that is, peculiar to you. So you can create an instance where you only use the log class, and you have only data, use only data. You can create an instance of the log class such a way that you can pass in both data and pass in the number of what data. So just think of it like variations, right? Variations of the classes that you can actually create an object out of, right? But I want to do something. I want to just, stylishly introduce inheritance, the concept of inheritance. I'm going to create another class called auth log, more like authentication, and it's going to, now let me just use the word, it's going to inherit from the log class. Okay, so don't worry, just follow me, right? It's going to inherit from the log class. I'll explain. So I'm inside this particular class, I'm going to create a constructor that, takes a data, a string also, right? And then, don't worry, some of you, like I said, I've gotten into much more complex stuff, so you'll catch up. Don't be scared. You'll catch up, right? So just try to read the code, but I'll explain. So this is just basically just creating a string template. Again, 10, okay? And then Okay, so this is one constructor. And then another constructor that will now take the number of data, which is of type int. And with this one, it's going to use, and I'm going to introduce you to a new word called super. And then you'll be like, oh, what is going on? This young man wants to finish our head today. Well, yes, don't worry, your head will finish, but to come back together. Okay. So this is basically inheritance, right? So let me just, before we'll get into it in a bit, but let me just run it, right? So think about this, right? Inheritance, just like you know what inheritance is, right? You know, let's say your parents actually, you know, move on, right? And then they leave something behind for you, right? So that's like your inheritance, right? So they leave something behind for you. That's your inheritance. So what the interesting thing about inheritance is, for you to inherit something, you need to have access to that thing. You need to kind of, in a way, belong to that thing, right? So that's what this colon here does. So we are basically saying that this class wants to inherit from this class. So inherit means, so when you actually say you want to inherit, it means you now have access to everything that that class has. So that's what inheritance does. So if you're inheriting your dad's wealth or your dad's property, right, being in the will means you have access to everything that he actually gave you access to, right? That's just actually that. So just think of it. That's basically what inheritance is. But we'll now look at it from a code perspective. But to be able to inherit for a class to be able to inherit this class, we have to open it up. So we use a keyword open. Don't worry, we'll get into inheritance, but I just want to explain Kotlin secondary constructor, right? Now, I just want to run this, and then from the, you know, okay, so, sorry, still having this, I've commented out this guy, so I didn't comment this one out. So I'm going to create an object here of our autlog class, right? Because it's inheriting. So that's, we're just going to use that. And then I'm just going to pass in, let's say, bad password, right? So basically, secondary constructors, like I said, just think of it as kind of giving you a variation. So you can see what I just passed in bad password here. Now, I created an instance from this autlog, right, which is this guy. And I am using, so because I passed only one thing, I just passed in only one, right? It now calls this particular word constructor. It calls this particular constructor. So I'm using this variation and I'm passing in, of course, it's expecting a string, which the string I passed in here is bad password. So now that constructor, so this colon is what's still inheritance. It's more like pointing to this. So I'll explain what this is in Kotlin, right? Also in Android. So that's why it now prints, it gives you from Kotlin, from autlog, bad password. Now, this here, right? Excuse me. Yeah, so it's basically from what this print statement. Okay, so we don't have 10 here. So this 10 here is like a default. We're passing in only data, which is just the string. But of course, it now uses 10 as a default. So you have this from autlog, right? This plus sign is just concatenation, right? Remember, string, right? So bad password, like we have here, bad password, and then we now have what 10 times, right? It's basically just using this guy here, right? This is basically what it is actually what printing, right? So the data here is bad password, and then the number of times it takes this default, which is 10, right? 10 times. Now, but if I give it, let's say 20, let's see what happens. So that now it then what calls this particular word constructor. It calls this particular word constructor, right? Because this particular constructor takes in two properties or two parameters, which I have provided to parameters, right? So that's basically just, about secondary constructors, right? That's just all about secondary constructors. Don't worry, we're going to get into inheritance. So I know you may be saying, what is all this? What is all this? You understand soon. But like I said, it's called secondary constructors. Just think of it as more like a variation of your class, whereby you're able to instantiate that class with just the parameters that you want. So if you just want to use only one, if you have only one parameter, let's say a class that you can have a class that has 4 constructors, right? And in each of those constructors, the first one takes only one parameter, second one takes 2, third one takes 3, the other one takes 4. But in a case where it's only one parameter that is available, right? When you create an instance, it uses the constructor that has one parameter. So it won't throw any error and tell you that it is expecting some other thing, right? So that's actually that's basically that, right? That's basically that. But let's just because of our time, let's quickly just jump to inheritance, right? Let's now really talk about it, like in depth. Let's talk about it. So inheritance, right, is actually a very key feature of OOP, that's object-oriented programming. So what it basically does is that it allows a user to create a new class. Now, that new class is called a derived class. We call it a derived class because it was derived from something, right? So inheritance basically allows a user to create a new class, or what's called a derived class, from an existing class, which is called the base class. Okay, so the derived class inherits all the features from the base class, and can even have additional features of its own. So like I said, thinking about it, right? Let's say your parent, your dad, your mom, whatever, they have lived a good old age, good old age of maybe 100, 120, and they, decide to give up the ghost, and then they leave, everything. They just leave their hope, everything they own to you, right? So you're inheriting, you're just inheriting from your parents. Now are like the base class, you are the derived class. So everything you have, every new thing you do, everything you do is based on, it's a derivative. You derived it from your parents, right? So you can also add a new feature. I like to use this example a lot, right? Let's say one of the things you inherited is a company, right? Is a company, and you can, everything, if they give it to you, everything is yours, right? But you can decide that, okay, well, in the company my dad gave me, there's no marketing department. You can decide to add a marketing department. And the reason you're able to also do that is because somehow there's a structure that allows for that. The structure could probably be a financial structure that allows for that. Okay, so that's actually what the kind of what inheritance is all about. So, but the question is, why do you actually need inheritance? Why do you need it in, when it comes to programming and the likes? Now, let's look at this scenario. Okay, let's say in your application, right? Let's say you're creating an application, right? And you want, let's say, you want to have 3 characters. Let's say a mathematics teacher, a footballer, and probably a businessman, right? So look at 3 different distinct characters: a math teacher, a footballer, and a businessman. Now, all of them, they are all characteristics of a person, right? They are all aesthetics of a person. They can talk, right? They can walk, they can eat, right? Whatever you want to actually, whatever characteristics you want to actually pick out. Now, they also have some special skills of their own, right? Like the math teacher is good in math. The footballer can play, right? Probably whoever. I don't want to call names before they start saying who is my own goat. I don't have goats. They're all good footballers, right? But of course, everybody has choice. And then we have the businessman who can run a business, right? So it's possible that the math teacher can't actually run a business. So each of them have their own special skills. Now, you can now individually create 3 classes who can walk, who can talk, and can perform their special skill, right? So this is it. Let's actually kind of do a cool thing. So I think this this thing is now now too busy. So let me probably just Or let's save this. Let me just save it and call this what? Um, I'll just call it OOP, right? OOP1 or OOP intro. Okay, so I'm just gonna save that. So that should actually just save, and then let me just create something new. So so we're talking about inheritance, right? Talking about inheritance. So let's see. The math teacher, right? The math teacher. So the math teacher can talk, right? Can walk, and can teach math. So, like I said, you can actually create 3 individual classes for all this, right? For 3 of them. The footballer, what can he do? Can also talk, can also walk, and can play football, right? And then, of course, the businessman can also talk, can also walk, and then can also run business, can run business, right? So in each of these classes, right? In each of these classes, what are we going to be doing? We're basically going to be copying code. Because if you notice, all of them can talk, all of them can walk. So imagine creating a class, right? And you want to create classes for each of them. That means we're going to be repeating codes that shows they can talk. We're going to be repeating codes that show they can walk, right? So we're going to be repeating code for walk and talk for each of them, right? So let's say if you want to add a new feature, eat. That means we'll have to now add a feature for each of the classes. We have to come here and add a feature for eat. We have to also come here, add a feature for eat. We have to also come here, add a feature for it. Like, see how we are actually just duplicating codes. And that's one thing you don't really want to actually avoid, because it can actually lead to having an error. You can have a lot of errors, right? So it is just going to be easier to create just one class called person that can talk, walk, and then eat, right? And what happens is the math teacher, the footballer, and the businessman, they just inherit from this class. So if you want to add a generic feature that 3 of them can do, you just do it in the person class, and these other guys just inherit it. They don't need to start declaring it again in their own respective classes. So the math teacher now becomes a derived class, because it will now inherit everything in the person class, meaning that since it's inheriting the person class, it means that the math teacher can also talk, means the math teacher can walk, and they can eat. So the person class becomes the base class, right? So what now happens is that the math teacher can now have his own function. Apart from the 3 basic things here, he can now add his own teaching of math, because that is peculiar to the math teacher. It's not peculiar to the footballer. It's not everybody cannot teach math. Everybody cannot play football. Everybody cannot run a business, right? So this actually makes your work, a bit cleaner. So how do we actually implement it in code? How do we implement it in code? So let's implement it in code. So first of all, we create our person class, right, which is the base class. So what do we say? I'm going to say class person. So the base class, because you want to inherit from it, you have to open it up. So we use the keyword open. Sorry, and remember, you shouldn't do that inside a function. You need to be very careful. So open class person, right? So let's just use this, right? So for a person has an age. So we're going to be using a primary constructor and has a name, right? And I'm going to just use my init block to kind of initialize the name, right? So I'm just going to say my name is Ima, and then also going to print my name is, okay, sorry, my age is 16, right? So just something to initialize when you're creating an instance of that person class. So for the math teacher, so let's create a class for the math teacher. So what happens? The math teacher is now going to inherit. So we want the math teacher to inherit the word person what class. So how does he do that? Of course, we use the colon to to actually indicate that inheritance, or another word you actually hear, which is the most common, is extending. You're extending a class, right? But that math teacher can have an age of type 8, right? And can also have a name of type string. But remember, when is actually inheriting the person class, and the person class takes two things, right? Which is what? Age. So we're just going to call the age, and then we'll call the word name, right? So this is actually how you would just inherit. But since he's a math teacher, he has his own special function. He can actually teach math. So I'm going to create a function called teach math, and then just print I can teach math, right? That's just that. So okay, Ahmad, go ahead.
Yes, sir. But
Yes,
since a person class has age and name
yeah,
as that's why are we also rewriting age and name in the math teacher class?
because when this is a class on its own, the math teacher is a class on its own, right? And when you're actually going to create an object of that, you have to also pass in the age and the name. So this age and name is going to be passed into this math class. But it's, remember, you're also inheriting this guy. You have to carry this guy along because you are inheriting the age and the name property, right? You're inheriting the age and the name property of the base class, which is person. So you also have to give, there has to be that, what word will I use? There has to be that opportunity to pass in an age and the name. Because if I remove this, right? If I remove this now, right? So when you're now creating an instance of the math teacher class, how do you pass in name and age? Because by definition, this class does not have any parameter by definition. But you have to put this word in, because the base class you're extending, you must give it an age and a name, because every person must have an age and a name. Okay, does that clarify things?
Yes, sir. That means
Okay.
the age
Yeah.
and name belongs actually to the math class.
Sorry?
That means the age and name properties, parameters, they actually belong to the math class itself, right?
Yes, they belong to the math class, right? Because but they are extending from the base class. This particular ones belong to the math teacher class. Okay, so I'm going to let's just do for the footballer. So for the footballer now, just going to modify a few things. Let's just do, right? Same thing, age, name, but his function is that he play football. And then I'm just going to change this to I can play football. And for the, okay, so let's just do for 2, right? So we don't take time. So now, since we have that, let's now create an object, right? Let's now create an instance of the class. So I'm going to say val, of course, you can use any, what's it called? Any name. So I'm going to say teacher, or let me say math, teacher, right? The math teacher. That's just a variable name. And then I'm going to now say call the class, which is the math teacher class. And then I'm going to pass in a name and a an age and a name, right? So for age, I can say 25. For Name, I can just say Adalinda. Let me use someone else, right? And so that's that. And then I can actually also now, because with the mteacher object, I can have access to what the teach math what function, right? And the teach math function actually prints something. So let's run this and see what we have, right? So when we run this, you can see here, remember, you see that it's actually what's running this initialization, right? And inside here, it says my name is what, Ima, and then 16. But let's see. Okay, so it says my age is 16 and I can teach math, which is, I can teach math is okay, this function. Yeah, this function, which is this one, right? And then for the math teacher, yeah, so we have 25, and then we have Adalinda. Okay, so yeah, I think we're missing something. Okay, so here I'm actually giving a default value. I shouldn't give a default value. So my name should be name, yeah, which is this one. And then age should be age, yeah. I was giving the default value. That's why we are still seeing Iman 16, even after we passed 25 and Adalinda here. So we should now see, yes, my name is Adalinda. So when you pass in the age right here, right, because you are extending this person function, it means that this guy in it will also run for you, because you're inheriting everything that this guy have. So this initialization is part of the base class. So the base class will also run for you. So it takes this age, right, and matches it with this, right, which then of course runs this guy for you. Okay, that's actually that. You can do the same thing for the footballer. I could just say F ball, and then I'm going to say footballer. For age, I'm going to say 31, and I'm going to say Okocha, right? Yes. And then I'm going to now do F ball dot what's the function we had there? Play football, right? Yes, that should be the function we had. So when I run this now, I should still have, my name is Adalinda, my age is 25, I can teach math, and then I have, my name is Okocha, my age is 31, I can play football. Okay, so that's actually, that's just the basic stuff about inheritance, right? That's just it. But a few things I want you to note, right, about inheritance is just something to note is that if the class has a primary constructor, the base must be initialized using the parameters of the primary instructor. Okay, it must be initialized using the primary constructor, the parameters of the primary constructor. Now, this is an example of what I'm saying. Now, assuming you have in my footballer class, I now add a parameter called club, or let me use country, right? So you notice that I don't have country in the base class, right? I actually don't have country in the base class. Okay, but if I run this, of course it will actually throw an error because I have not initialized, I haven't given so you can see there's no, it's expecting a value for the country, right? So whenever your class has a primary constructor, like the derived class, when there's a primary constructor, the base class must be initialized using the parameters of the primary constructor. So what does that mean? Here, I'm now going to do init, right? I could just, this is just me. Let me just do print line. I just want to do something now. So print line. I could say, just to be sure that what I'm doing works, football player And then let me get the name. I just want to write a sentence here of age, and place for club, right? So here, I'm now going to pass in a club, a country, rather, I'm going to say Nigeria, right? Sorry, country. Country. So let's run this, and then we should actually have something. So you can see football player or coacher of age 31 and plays for Nigeria. So I think I spelled Nigeria wrongly, right? So that's actually that. Okay, so it's possible for you to have an extra parameter that is not in the base class, right? It's very, very possible that you have what's that. So, but in the case where you don't have any primary constructor, in a case where you don't have a primary constructor, right, what do you do? When we talk about primary constructor, you can see that this person class that we created, this is a primary constructor, right? I hope you have not forgotten. But in the case where you don't have a primary constructor, right, that is where each base class has to initialize the base using the super keyword, right? I think that was the previous example I gave. Let me see if I can pick that. Okay, so one compiler, my account, I saved that now. So okay, so you can actually see your codes. I just started doing this stuff. So let me open what I have. So no, not this one. Okay, yeah, this one. Okay, so here that we had this. So you can see that when the class, right, when there's no primary constructor in the base class, if you check here, our base class, which is log, there's no primary, right? There's no primary word constructor, right? So, but when you're using it, each of those class, you have to initialize the base using the super word keyword, or is it that, or you delegate to another constructor to do that, right? That's why you now have this particular constructor that is what extending and using the super word keyword, right? So it's basically more like pointing to the base class. That's what the super actually what does. It basically just points to the base class. So that's just something to kind of take note of. Yes, Ahmad, go ahead.
So the two constructors in the, can you show the code very well, please? Yeah, in the auto log.
Auth log, yes.
Are they for the yes?
Yes, they are for the auth log.
Okay.
Yes, they are for the auth log. Yes, they are for the auth log. So you can see the first constructor takes in only data, but the second one takes in data and number of data. So it takes in 2 parameters. The other one takes in 1. It depends on which one you want to use, right? That's
okay.
what
What
we talked about.
front?
Yes. What about what?
The this in front of the first constructor.
Okay, so now let me explain that. Yes, how did I skip that? Okay, so this is actually an expression, right? And basically what the expression does, it kind of used to denote the current receiver. Okay, it's used to denote the current receiver of a particular let's say value, a function or whatever, right? Now, so when we say this, we're referring to the auth log class. Okay, when we say this, we are referring to the auth log word class itself. So that's why this means you're pointing to the auth log. Super means you're pointing to this other one. You use it a lot in Android. In fact, you actually understand it more when we get from next week. No, yeah, from next week. Yes, when we get into Android. But just like you use the super to call the base class, you use this to what call this particular word class. So what we're saying here is that look, this constructor that takes this is extending from the auth log word class. And if you notice, what we are just doing in this auth log class We are just, kind of passing this guy here. So we're giving it a default value, right, of a string, right, and a value, which is, we're basically calling this guy here. This is basically what we're calling, just this, right? Okay, well, I'll get another example, right? I think I'll just use another example too, and then we'll probably explain that. But let's just round up. Whoa. We have just 4 minutes of our time, and I needed to talk about something. Okay, so I think I should be able to finish that in the next 5 minutes. Okay, so let's just finish up, right? We'll definitely touch OOP briefly before we get into Android on Monday, but sorry, on Tuesday, yes, which is our next class. Let's go back to our code. I think that should be this one. Okay, yeah, that's this one. So the last thing I want to talk about is overriding member functions and properties, right? So if the base class and the derived class contains a member function or probably a property that has the same name, you can actually, in fact, you actually need to override that function using a keyword called override, right? And then of course you have to open the key, use the open keyword for the member function on that base class. So what I mean is this. We have okay, let me just close this. I'm still going to just click here. Okay, just comment that out. So I'm still going to create an open class. So I'm using open because it's I'm going to inherit from it, and then I'm giving it an empty constructor. This is an empty constructor. There's nothing inside. I'm passing in an empty constructor. Now, but inside this, I have just a function. I don't even have a property, just a function to display what age. And then it takes an age of type integer. And what that function does is that it now prints age. Okay, so just this is what this function does. Now, when I want to create a class, let's say I want to create a class boy, or let me say student, right? And I want it to inherit the base class called person. So I use my colon, and then I'll call person, and then I have to pass in this the parentheses, right? Now, if I want to, sorry, I need to bring this down. Okay, so for me to be able to access this function, right, I have to open up this function, right? I have to open up this function. So I'll open this function up, and with that, I can now override this function. I'll just say override. So use a small letter, override. And then override function called display age, right? Override the function called displayed age that takes in an age of type int. And since I'm overriding it, it means I can do whatever I want with it. I can update it the way I like. So instead of it to just print my age is age, instead of it to print my age is age, I want it to print my age is age minus something. So let's say my age is age times 4. So I'm kind of modifying what this guy should actually do, right? So of course, in my main function, sorry. Okay, sorry. My main function, I'm going to just say var student, should be var, but anyway, and then student, right? Sorry, student class. Sorry, trying to type so fast. Student class, right? And then I can now say student Nope. Small letter. Student dot display. Run this, right? Okay, so where do we have? Oh, sorry, I didn't even put a quotation mark here. Okay, yeah, sorry about that. Okay, so you can see my age is what 40, which is 10 times 4, right? That's what 40. So I can only override this because this guy is open. If I do not do this, right? If I don't do that, if I don't open up that function, you can see that error display age in person is what final and cannot be overridden, right? But when you open it up, it means that you now have access to it, right? So overriding, you can now what kind of, so the whole concept of overriding is you're basically just using it the way you want to use it. That's also, you don't want to take the implementation that is done. I don't want to do it the way it is done when it was defined in this class. No, I want to do it in my own way. So that means you have to override it, right? That means you have to override it. Okay. So that's actually that, right? I think we've gone past our time by 2 minutes, right? We've gone past our time by 2 minutes. But do we have any question regarding this before we call it a time out? Any question? Okay. Okay, so I'm going to take it that there's none. Okay, so expect your task on the LMS this night. Well, definitely when I post the task on the LMS, I'll just drop a message. But do well to check. If it doesn't come this night, definitely by tomorrow morning it should be up, right? And then you have now till Sunday night to submit. Okay. Yeah, so that's basically that. Thank you guys very much for your time. And yeah, we're gonna see you on the workspace. Have a wonderful weekend.